All right, let's dive right into this explainer. Today we're looking at how environmental engineering has basically become the ultimate future-proof career path. Seriously, if you've been looking at the shifting global landscape and wondering, hey, how do I secure a high-demand technical career that actually makes a tangible difference? Well, you are absolutely in the right place.
To kick things off, we really have to ask ourselves, as the whole world races toward a sustainable green economy, which discipline is building the actual physical infrastructure to get us there? You know, for decades, environmental concerns were kind of treated as an afterthought, right? Like just a niche subfield of civil engineering. But wow, not anymore.
Just look at this number. According to the International Labor Organization, global green initiatives are going to generate over 24 million jobs by 2030. 24 million! That is a massive, completely non-optional demand for specialized engineers. We're talking about a fundamental restructuring of global industries here. And environmental engineers? They're the ones bridging the crucial gap between physical infrastructure and our actual ecological survival.
So in this explainer, we're going to map out this entire landscape. We'll cover the global demand, peek inside the degree curriculum, compare traditional versus emerging engineering, look at some practical applications, and finally, check out those global salaries and job outlooks.
All right, moving right into Section 1, Global Demand for Environmental Engineers. Let's explore exactly why this field is experiencing such explosive growth right now. Look, environmental concerns just aren't optional discussions anymore. They are literally critical priorities shaping government policies and corporate strategies all over the planet. Driven by international accords like the Paris Agreement, industries are completely restructuring. Environmental expertise is what's directly driving innovation in modern manufacturing today. To put it into perspective, the U.S. Bureau of Labor Statistics projects a robust 7% job growth for environmental engineers through 2033, which is significantly faster than average. And over in India, massive, multi-billion-dollar initiatives like the Smart Cities and Jal Jeevan missions are aggressively pushing the demand for sustainability-focused engineers.
Okay, Section 2, inside the degree curriculum. What are the actual weapons and tools you need to conquer these global challenges? Let's take a look at the academic coursework that actually gives graduates that massive competitive edge.
If we look at the rigorous Anna University BE syllabus, you can see how things logically build up. You start with core math and chemistry in year 2, and then ramp all the way up to advanced wastewater design and an 80-day industrial internship in year 4. Listen, this isn't just about, planting trees. It is heavily rooted in hardcore civil engineering. You're still learning strength of materials and structural mechanics. But by years 3 and 4, you're totally specializing in water supply engineering, designing municipal distribution networks, and tackling air and noise pollution control with serious atmospheric physics.
And guys, this is not just basic theory. You are going to dive deep into mass transfer, reaction kinetics, and transport phenomena. Now, you might be wondering, why does this even matter? Well, because this level of high-level mathematical modeling is exactly how you analyze pollution dynamics in a real-world river system. You are literally taking experimental data and determining rate constants to solve incredibly complex pollution dynamics on the fly.
But here is where your true competitive edge in the job market comes from: heavy software integration. Students master incredibly powerful tools like EPNET, WaterGem, and WASP to simulate and optimize complex networks. So you aren't just staring at old-school blueprints. You are actively using the exact same simulation programs that top-tier consulting firms and government agencies use right now to design smart cities.
And to achieve this level of mastery, you'll be learning from the absolute gold standard reference books in the industry. We're talking about texts like Metcalf and Eddy for wastewater engineering and Stephen Chopra for surface water quality modeling. Mastering the literal Bibles of the industry? Yeah, that puts you leagues ahead of the competition.
Moving on to Section 3. Traditional versus emerging engineering. Let's see how all this coursework actually translates from classroom theory to the modern professional battleground.
I love this part because it perfectly dispels the myth that environmental engineering is just waste removal, right? Historically, the job was super reactive, like building a landfill or slapping a scrubber on a smokestack and calling it a day. But today, it is all about system-wide circular economy models. You're dealing with AI-driven smart agriculture, designing carbon capture technologies, using satellites for drought prediction, and running complex corporate ESG models. This is exactly why environmental expertise is so vital to modern manufacturing. You're not just cleaning up messes anymore. You are designing processes that prevent pollution before it even starts. That is a huge shift.
All right, up next is Section 4, Practical Applications and Advice. So what does it actually feel like to work in this rapidly evolving field? Let's step out of the classroom for a minute.
There's this great quote from a professional on Reddit who said that society absolutely will fulfill its needs one way or another. And that really hits the nail on the head. As an environmental engineer, your job isn't to be a roadblock to progress. It's to present actionable, scientifically sound solutions, so that when we build, we don't just steamroll the environment in the process. Your day-to-day is going to involve an unbelievable mix of fieldwork, process modeling, and ensuring strict regulatory compliance. You're really the architect of a cleaner tomorrow.
Okay, bringing us to our final section, global salaries and job outlook. Let's look at the treasure at the end of the journey. Because hey, doing good for the planet should definitely also mean doing well for yourself, right?
Based on data from the Bureau of Labor Statistics, your options upon graduating are incredibly diverse. You can work for state or federal governments enforcing key regulations, or you can jump right into the private sector working for major manufacturing and chemical companies. Over there, you'd be helping them design waste reduction processes from the ground up or coordinating massive environmental health and safety programs. You've got consulting, local government, really the whole shebang.
To give you an idea of the global earning potential, get this. The median salary for top-end federal environmental engineering roles in the U.S. currently sits at over $120,000 annually. That is huge. And if you enter the oil and gas extraction sector, experienced engineers who manage regulatory compliance and site remediation, they're regularly pulling in between $95,000 and $120,000 as well.
And over in India, the financial rewards are equally concrete. Secure entry-level public sector roles can start up to 12 lakh rupees, and experienced multinational engineers scale all the way up to a whopping 50 lakh rupees. Massive organizations like ONGC, NTPC, and the Central Pollution Control Board are actively recruiting right now. Plus, thanks to things like the EU Green Deal and huge infrastructure projects across Asia, Indian engineers with this degree have incredibly strong international job prospects. The financial ceiling is so high simply because your expertise is just that specialized and in demand.
So what does this all mean? It means environmental engineering is no longer just some tiny sub-branch, it is literally the front line of global infrastructure and climate survival. The blueprint for a completely sustainable global economy is already being drafted by the engineers of tomorrow. Armed with this competitive edge in high-tech sustainability, the only question left is, will your signature be on it? Thanks so much for joining me for this explainer, and we'll see you next time.